Hey guys, how are you? Welcome back to the channel. Today is day 38 of Upskilling myself, and today I solved 4 DSA problems as well as did some internship work. So yeah, let's see the DSA problems that I solved. So the first problem was palindrome linked list. So we have been given a linked list and we have to find whether it's palindrome or not. Okay, so if this is a linked list, 1, 2, 2 and 1. If you see, this 1 is equals to this 1 and this 2 is equals to this 2. If you see in this example, if we partition the linked list into two halves, this half should be equals to the reverse of this half, right? So we are doing the same. We get the mid of the linked list, then we reverse the linked list after the mid, and then we check if the this start over here and the mid of next, which is this, are equal or not, and then we advance this both. Okay, so when we reverse the second half of this linked list, it would be 1, 2, 1 and 2, right? So now we'll put our start over here on 1 and mid plus 1 will be over here. So these two are equal, we advance both. These two are equal, and then this advancement of mid will be over here on the null pointer. When it is null, we return true. We have done the same thing. We have defined slow and fast pointers to get the mid. Then we have defined previous, current and next, and we have done this process to get the mid of the linked list. We have done this process in the previous problems, and then we get the left pointer and the right pointer. Then we compare both of the pointers. If they are not equal, we return false, and when the when the right pointer is pointing towards the null, we return true. So the next problem is maximum sum circular subarray. So we have been given an array. Let's take an example of 1, 2, minus 2, 3. Okay. So how to get the maximum sum of the subarray? So we can either get the sum of a particular element, which is 3. 3 can be the maximum sum, or we can also consider 3, 1 and 2, which will accumulate 6 as a sum, right? So we consider it as a circular array. So how to solve it? If you see 1, 2, minus 2 and 3, the total sum is 4, right? And then we reduce the minimum sum, which is minus 2, we get 6, right? Because 4 minus of minus 2 is nothing but 6. So we are doing the same. We calculate the total sum and then we reduce the minimum sum from it, and then we return the maximum of the maximum sum and the total minus min sum. Okay, so we define total is 0, the current max is 0, and the maximum sum is int min. Then the current min is also 0 and the minimum sum is int max. Okay, then we traverse the array and we set the current max and max sum. Then we set the current min and the min sum. Afterwards we get the total sum, and then if the max sum is less than 0, which means all the elements are negative, then we return the max sum, which is the maximum negative that we found in the array. Else we return the maximum of the max sum and the total minus min sum. So the third problem is game of life. So we have been given this matrix over here, as you can see. So we have to change the bits or the numbers. Let's say 0 means a cell is dead, 1 means a cell is alive. Okay, so if you see over here, let's take an example of this cell. So this cell was earlier dead, but if you see its neighbors, 3 of its neighbors are exactly live, right? So when 3 neighbors are alive, then this cell would rebirth and it will be alive. Okay, and if a cell, let's take an example of a cell which died. Okay, so let's take an example of this cell. It was alive at start, but only one of its neighbor was alive. So later on in the next cycle it died. So we have to do the same. Any live cell with fewer than 2 live neighbors dies. Any live cell with 2 or 3 live neighbors lives, and any live cell with more than 3 live neighbors dies. Okay, by overpopulation. And the last point was any dead cell with exactly 3 live neighbors becomes a live cell. Okay, so how to solve it? So we get the number of rows, number of columns. We define a vector, which is a copy of the board. Then we define a vector of pairs, which are the neighbors. You see the neighbors, and we have to multiply with the current index to get the position of the neighbors. Then we traverse the 2D array, and then we set the live neighbors as 0. Then we traverse through directions and set the count of the live neighbors. If the live neighbors is exactly 3, then we make the cell alive, and we can perform operations according to it. Then we'll copy the copy board into the original one, and this serves as the output. The final problem was reverse linked list 2. So we have been given a linked list and we have to just reverse this particular nodes over here. So we have been given the position of the nodes. At first you may be confused that we have to reverse the nodes with the values, but yeah, the test case was a bit confusing. So even I fell for that particular part, but yeah, these are the positions, and even it's not 0 index, it's a 1 index position. So I think the question description can be improved. So how to solve it? So we create a dummy node to handle null case, and we set the previous pre-reverse as dummy. Then we move the pre-reverse to the node just before the reversal part. Then set the current as the next of the pre-reversal and previous as null pointer. Then reverse till r minus left plus 1. The output that we get over here is the number of nodes we have to reverse. Then we connect the next of the first reversal and the next of the pre-reversal. Okay. So if there is no head and if the left is equals to right, which means these both are the same elements, the same positions, then we return head. We don't have to reverse anything. Then we define a dummy node. We copy the head into the dummy of next. Then we create a pre-reversal pointing towards the dummy. Then we move the pre-reversal to the node just before the reversal segment. So yeah, basic stuff. Then for the reversal part, we define current, previous. Then we reverse from 0 to the right minus left plus 1. That is the exact number of nodes. This is the basic code every time that we used to reverse the linked list. Then we connect the reverse part back. So the tail of the reverse segments points to the post reversal, and the pre-reversal points to the new head of the reverse segment. Okay, so pre-reverse next is equals to current, and the next of the pre-reversal would be previous, and then we return the next of the dummy. Okay. Then for the development part, I did some internship work and I did the revision of all the DSA problems that I solved till now. So thank you guys for watching and see you on day 39.